Good afternoon, everyone, and welcome to today's training session where we'll be looking at the FAAC B614 medium volume barrier. We'll be looking at just a few details around the product and a couple of tips to help you with your installation and make it as trouble-free as possible. So in today's session, we'll be looking at feature summary on the product, parts identification, the mechanical installation. We'll be spending quite a bit of time on the E614 control board, which is the heart of the operator. Taking a brief look at synchronized barriers, some of the accessories that are available, and then we'll have an opportunity for some questions and answers. As always, you as an attendee are muted at this point, so if you have any questions, if you wouldn't mind just typing them into the chat box, I'll try and get to those. Otherwise, you can save them up towards the end of the presentation. You'll have an opportunity to ask any questions you might have. So what I'll do is we'll start off with a short video, which is going to highlight some of the features of the B614. So that video should have given you a fairly good overview of the B614 barrier, and at least, if you haven't previously worked with one of them, it'll kind of make more sense having physically seen what the externals and the internals look like. So let's focus now on the parts identification. You can see obviously there's a main casing to the unit. There is an output shaft and a manual release, which sits just below the output shaft. Of course, there's a top cover that sits on top of the electronics to give that protection, and then there is a front door with a lock which locks the cover. The door itself is in fact screwed into place or bolted into place prior to the cover being fitted and locked. So it's the lock in the door actually really just releases the cover and then gives you access, or releases the top cover, which then gives you access to the front door if you need to remove it to adjust anything mechanically. Internal to the unit, we have the control board sitting on the top of the unit at an angle, making it fairly easy to work on. The balancer, which is where the springs attach, and we'll touch on that a little bit later. The main motor and gearbox, the lower spring fixings, so the springs fix on the one end to the balancer and on the other end to the lower spring fixings. And then we have the built-in end stops for raised and lowered. Okay, so the first step is to assemble the base plate and put that into the concrete. If you're throwing your own concrete foundation, you'll obviously have to set this into the concrete using the J anchors, which are shown. So you will pre-assemble the J anchors, leaving about 22 millimeters of thread exposed above the nut. And then you'll sink that into your wet concrete. If you're bolting the base plate down directly onto existing concrete, then you'll obviously use Chem set anchors and just fix it down straight to the concrete footing. If you are going to be casting from scratch, there's details on the wetworks to be found in the manual. First thing you'll need to just be sure of is which is the beam side of the operator and which is the door side, and install it appropriately into the wet concrete, also noting the aperture for the conduits, where the conduits will come into the unit. And obviously make sure the plate's horizontal and then allow that concrete time to cure. If you are going to be casting your own foundation, as mentioned, the manual does have a section on the foundation design, so that'll be the dimensions of that foundation, including the reinforcing that's required. And that's for your maximum barrier configuration, which will be a 5-meter barrier. Once your base plate has been installed and the concrete cured, we then remove the nut and washer, which will then expose the 22 millimeters of stud. We'll drop the outer casing onto those 4 hold-on bolts and fix them in place with the washers and the nuts, torquing those nuts down to 15 Newton meters. You'll see throughout the manual, whenever there's a fastener involved, the manual will give you the suggested tightening torque. So once the body is fixed down to the foundation plate, we need to look after our cables that are coming into the unit. So that'll be both your 240 volt supply as well as any control cables. So you arrange the cables inside the barrier, fixing it with the cable ties that are provided. You can use those to route the cable up through the side of the unit. And where they emerge at the top, there is a cable termination. You'll remove the screw and washer from the cable termination, swing that back. You then basically bring your cables in and then use the screw and the washer to then again close that cable tie. It does have a foam strip which both obviously grips the cable, but then also provides you with some degree of insect proofing to prevent your insects getting up onto that control board area. We're going to look at the manual release very briefly. So the manual release is located below the output shaft to which the beam attaches. So in order to operate that manual release, you'll open the lock cover. So you'll basically just swing that out of the way. You'll insert your key and then turn the key either anti-clockwise until it stops to release the barrier, or turn the key clockwise until it stops to re-engage the barrier. So very simple to use, very intuitive. Okay, we now need to fit the beam to the output shaft. So we begin by manually releasing the barrier, as shown. We'll turn the key counterclockwise. We will then rotate the balancer arm to bring the drive arm into contact with the lowered end stop. Now, the lowered end stop is going to vary depending on whether the barrier is right-handed, in other words, the beam is out to the right as we approach, or left-handed, the beam is out to the left. So either end stop number 1 or end stop number 2 is going to be your lowered end stop. So you will rotate the balancer to bring that drive arm up against the lowered stop for your particular installation. You will then fit the plastic guide into the output shaft. So you're just going to screw that into the output shaft, which then allows you to easily fit the attachment plate horizontally onto the output shaft until it contacts the circlip, which is number 3 in that drawing. You'll then remove the plastic guide and fit the adapter. And once the adapter is fitted, you'll fix that in place with the washers and the bolts, parts number 3, 4, and 5 in that drawing. And you'll torque that to 60 Newton meters. You'll then fit the beam in the horizontal position, and it'll be easier when you're doing this to support the beam at the far end with a trestle or a workhorse of some sort. And once that's in place, you'll fix the counterplate with the provided bolts and washers, and you'll torque those up to 25 Newton meters. Lastly, you'll fit the cover over the counterplate, and you'll fix that with the screws provided. And of course, before doing this, you would have prepared the beam, incidentally, by fitting the rubber bumper on the bottom end of that beam, or the bottom surface of the beam, and also the LED light strip on the top surface. I should have mentioned that earlier, but that will all be fitted and cut to length before fitting the beam onto the output shaft. And then lastly, you'll fit the end cap, and you'll fix it with the screws that are provided. Once that's done, your beam arm is now fully installed. And the next step is the fitting of the balancing spring. So to fit the spring, the first thing we need to do is determine the spring requirements for your installation. So there is a table in the manual. You can see here we're showing table 17, which is for the round beam, the S-type beam balancing in this case. So the first thing we do is we look at the leftmost column, and we look at what are we fitting on this particular site. In this case, I've used the example of a beam with a foot. So there's a foot at the end to support the end of the beam. We work along the top row of the balancing table. In this case, we're going to be fitting a 4-meter beam with foot. So we move across to the column, which ranges from 4 to 4.4 meters. And then we just extrapolate from the left-hand column and the top row. And we come down to a single spring. We can see there's an image of one spring in that block, and it's denoted 5A. So what 5A means is it's point number 5 on the balance beam and point number A for the bottom attachment. So I'll show you what that means in the next slide, but just remember, single spring connected to 5A. So as you can see on the balancing system, the balancing beam has 5 holes on either side of the beam, numbered from 1 on the very inside to 5 on the outside. Which side you use depends again on whether you have a right hand or a left hand beam, but of course the spring must be tensioned when the boom gate is lowered, and then obviously relaxes as the boom gate raises. So you'll see very clearly which side you need to be connecting to. In this case, we knew we had to connect to 5A. So 5 is the outermost hole on the, in this case, on the left-hand side of the balance beam, because we have a right-hand boom gate. And then A is the, let's call it the lower right-hand fixing hole at the bottom of the unit for the bottom of the spring. So we know that we need a single spring hooked between 5 and A. So we raise the barrier at this point, and we put the manual release to automatic. So we lock the barrier in the raised position to prevent it falling down. We then align the bushing number 1 and the turnbuckle number 2 with the appropriate hole, which is 5 in this case, and we fix it in position with the provided bolt and washer. For a single spring, we then lengthen the turnbuckle. We hook the spring onto the turnbuckle, and we then hook it into the appropriate slot at the bottom of the barrier, in this case slot number A, and then we slightly tension the spring by shortening the turnbuckle. So that's if we were fitting a single spring. If we look at the case where we had a double spring, slightly different process. We need to lengthen the turnbuckle as before. We then connect the plate shown number 1 to the appropriate slot on the barrier base. We secure it with the element marked X. We then connect both springs to that connecting plate. And then the other side, we connect to a hanger plate, and we connect that to the turnbuckle. So once again, we slightly tension the spring by shortening that turnbuckle. Again, remembering we haven't balanced the spring at this time, we just slightly tensioned it. The next step is we actually need to balance the beam. And we do that by releasing the barrier, release the manual release, and lower that barrier manually to the 45-degree position. And what we're looking for is we're looking for the arm to be neutral at that point. So from that position, if the beam wants to lower further, we need to tighten the turnbuckle, in other words, make the spring tighter. But if the beam wants to raise, we then want to loosen the turnbuckle. But what we're looking for ultimately is for that beam to be neutral at the 45-degree point. When that's the case, the beam is then perfectly balanced. You could at that point re-engage the manual release mechanism, unless of course you need to adjust your end stops. If you need to adjust your end stops, the barrier is supplied with the end stops adjusted at the factory for perfectly vertical raised and perfectly horizontal lowered. But there might be cases where perhaps the concrete footing is on a slope and you need to adjust that slightly. If you do need to adjust it, you do that simply by releasing the lock nuts, which are denoted 1 in this case. One of them is going to be in the raised position, one is going to be in the lowered position. You're going to then hold the bolt number 2 with a suitable Allen key to prevent it rotating, and then you'll adjust the end stop position with bolt number 3. You can either screw that in if you want the barrier to travel slightly further, or screw it out if you want to travel slightly less. And of course, once you're done with that, you'll retighten those lock nuts and then re-engage the manual release. And at that point, your beam is hopefully balanced and your end stops are set appropriately for your site. The next step is we need to earth and close the front door. So there is a cable provided for earthing the door to the barrier chassis. So you'll earth that, fitting it fit that earth cable to the various posts with the supplied nuts and washers. And then once you're done, you will insert the door, the lower slot of the door, into place at the bottom of the chassis, close the door, and then fix it in place at the top with the 2 bolts and washers provided. That'll then fit the front door to the unit, and then we will just look at how you close the top lid. With the cover inclined, okay, you'll insert the markers, which are shown as 1 here, into the slots, which are highlighted here as 2, and then you will lower the other side of the lid into place. Once that's lowered into place, you can then lock that lid by turning the key anti-clockwise, and then just confirm that the cover is in fact properly closed by lifting both the beam and the front edges, just to make sure that that cover is firmly in place. But of course, we need to do some programming on the control board, so we won't be typically closing the cover at this point. So speaking of the control board, let's have a quick look around the E614 control board, because this is where really the smarts of the system lie. So you can see up on your screen now a general board layout of the E614. We've got J1, which is your incoming mains power supply. We've got your electric motor, which is connected to J23. We've got the built-in encoder, which will be plugged into J11. There are J18 provides lighting connections for your beam lighting, so that's an LED strip that will run in the beam itself. The integrated traffic light, which is an optional extra, which is in the lid of the unit, red and green traffic lights, that gets plugged in if used into J21. We then have a bank J6, which are your inputs and your power for your accessories. We have J10, which is an input for your opening loop, which is an external loop detector. This board does not have built-in loop detectors. You'll have an external loop detector which will connect into J10 for an opening loop, and you'll have similarly J13 is an external loop detector wired in for your transit loop, which is the loop that will close the barrier once a vehicle has passed through. There is a bus to easy connector, the standard red connector that you see on all our control boards for bus to easy connections. There is a bank of outputs, a total of 4 outputs, as well as some further accessory power output connections. There's a connector J16, which is for a warning lamp, if you wish to fit that, a 24-volt DC warning lamp. A socket for an XF433 radio receiver, which will provide radio control of the unit as an accessory. And then lastly, J8 is a connector for the backup battery, if again an accessory, if that's going to be fitted. So let's look at a bit more detail, the incoming mains power. So firstly, you will crimp the earth wire of the main supply cable coming into the unit. You'll crimp that to the terminal provided in the kit and connect it to the earth post as shown, as circled in that diagram. The actual grounding between the control board and the chassis is already done at the factory, so you don't remove that, you just leave that in place. So your earth terminates on the post as shown, and then you'll connect your active and neutral to the terminals neutral and live of J1 respectively. And that will effectively bring your 240 volts supply to the board. The board itself has a built-in power supply, so everything is integrated on the control board. The 240 wires directly into the board. In terms of your inputs, you have an open input, which is a normally open contact, which typically commands the barrier to raise. So bridging that open input to ground will cause the barrier to raise, and sometimes to lower, depending on the logic that you select for the barrier. There is a dedicated close input, which is also normally open, and this input always commands the barrier to lower under all circumstances. And that's, of course, providing that there's nothing in the way preventing the barrier from lowering, so something in the beam or on the loop. There's a stop input, which is a normally closed input, so if it's unused, must be linked to ground for the barrier to operate correctly. And this will basically block barrier operation, so it's an emergency stop. It can also function as an input for a closing PE beam, and that's subject to configuration, which can be done later. We're going to talk about configuration later on when we look at programming of the board, but the default is that this is a stop input. And then lastly, the last normally closed contact is an emergency input, and this commands emergency opening. So typically, this would be wired into your building fire system, where in the event that that contact opens, the barrier will automatically raise. The accessories power, 24 volts DC, limited to 500 milliamps. So this would typically be used for powering things like external loop detectors, radio receivers, PE beams, etc. Just note again, as I say, maximum of 500 milliamps can be supplied from that output. Looking at the external loops, there is that dedicated input for an opening loop. So this is a free to exit loop, typically would be on the inside of the property. A vehicle would drive up to that loop detector, the contact would close, and that will trigger the boom gate to raise. Similarly, loop 2 is the input for the transit loop. So this is the loop that's generally used underneath the boom gate, underneath the beam, to provide both closing safety as well as to automatically close the boom gate once the vehicle has passed or transited over the loop. These are both normally open contacts, so please note that. And they do utilize, or they do require, the use of external loop detectors. The outputs, there are a total of 4 outputs. They are all open collector outputs, which means that they are electronic outputs, transistor outputs, that switch a negative out under certain conditions. And those conditions are programmed in the programming, and we'll look at that in the advanced programming menu. Suffice it to say at this point that each of those outputs, being electronic, can only sync 100 milliamps per output. So when that output is activated, it will switch a negative to an external device, perhaps a warning light or a relay, up to a maximum of 100 milliamps. So programming of the control board, for those of you who are familiar with FAAC equipment, the programming is very similar to any other FAAC controller. All programming is done using a 2-digit display on the unit, as well as the 3 push buttons marked F, plus, and minus. So how does this process work? We'll touch on it very briefly for those who are not familiar. We press and hold down the F button, and when you do that, you'll see the first function, or the first basic function, appear on the display. And that function will be displayed there as long as the F button remains pressed. When you release the F button, the actual value of that function will appear, and that's going to be either the default value, if there have been no changes made, or the program value, if that value has been changed. But the value will show, and when that value shows, you can then change or modify that value using the plus and the minus buttons. So if you were looking at a numeric value like a pause time, 20 seconds, say, you could press the plus to increase or the minus to decrease. Or if you're looking at a logic, for example, maybe you're looking at EP logic versus A logic, you'll skip through the various logics or step through them using the plus and the minus buttons. Once you've selected the value you want with the plus or the minus buttons, you then press F to confirm that value and take you to the next function, which will then be displayed while the F button is pressed. The modified value of the previous parameter becomes effective immediately after you have changed it. You'll then proceed that way through all the functions until eventually you get to the last function, which is ST, or store, which allows you to then close the program. So in the store function, you'll either see a Y, which is the default, or you can change it to a no. So it's either yes or no. If you select Y and you press F button again, you will save all the settings. If you change to no and press the F button, any changes you made will then be reversed or reverted and lost. So it is important that you do acknowledge the Y as the very last step in the programming to store any changes that you might have made. So then pressing F confirms and closes the program, and that takes you back to the automation status view, which shows you the status of the automation. We'll touch on that in a moment. If at any point you wish to exit programming mode, so you don't want to go all the way through to the end of the parameters, you can just press and hold the F. While you're holding the F, press the minus key, and that'll move you directly to the ST option, where you will press the F button to acknowledge and exit programming. So that's just a shortcut to exit. There's nothing wrong with you stepping through all the parameters to get to the end either. Both of them will work. So let's have a look at the basic parameters. The very first parameter you're going to see when you press your F button is CF, which is the barrier configuration. And this basically sets up the control board for a particular configuration, or particularly a beam length. The default is 0.3, which is a beam from 4 to 5 meters. And the reason for this is that by default, the control board will assume that we've got the longest possible arm, and that means that all the settings on the controller, the speeds and the forces, will be set optimal for the longest possible arm. You can then change that, of course, at any stage. So you can reduce the 0.3 to 0.2 if your beam's between 3 and 4 meters, or to 0.1 if your beam is 3 meters, and that will then adjust the default parameters accordingly. So it is important to set that barrier configuration appropriate to the length of arm that you have. The next setting is DF, which is the default. That will typically say Y. In the first time you set up a unit, it says that all the values in the unit are defaults according to the factory defaults. If you've made any changes, this will read no, which says that there's one or more values that are different from the default settings. However, if you wish to revert the board to all default settings from the factory, you can just change that no to a Y using the plus or the minus key, acknowledge with the F, and then the board will be reset to default values. The next parameter we have is CT, which is the master slave configuration. The default is master configuration. We'll touch briefly on this right at the end of the presentation when we look at synchronized barriers, where you have two barriers working together. But in most cases, with a single barrier, you'll leave this as at the MA setting. Next parameter is the operating logic, or the functioning logic, and the default is EP, which is a semi-automatic step-by-step. What this means is that you'll pulse the open input to the control board once the barrier will raise. You'll pulse the open input again, and the barrier will lower. You can then change this logic to suit your site. The logics are very well described in the manual, and they're beyond the scope of this presentation. But the most commonly used logics are going to be EP, which is the default, which, as I say, is pulse the open input to open the barrier, pulse it again to close. Or you'd use the A, which is the automatic logic, where you would pulse the open to open, and after a preset pause time or delay time, the barrier will auto close. And so logically, the next parameter we have is PA, which is the pause time, which would apply to automatic logic if you selected it. The default is 20 seconds. That can be reduced anything to 0, which is immediate, all the way up to 2 minutes and 50 seconds. In fact, no, I lie, up to 9.5 minutes. They use 2.5 minutes, 2 minutes, 50 seconds as an example. But generally, that auto close time is going to be set somewhere between 15 and 30 seconds on your side. Next parameters are the opening and the closing speeds. The default values for these are set up by the control board when you select right in the beginning your configuration as either 0, 1, 0, 2, or 0, 3. So in the default configuration, which is configuration 3, you can see that the opening and closing speeds are set to 0.2, which is almost the minimum speed, because that is the maximum length arm. You can play with the speeds in this setting, so you can change them up or down to suit your site, just bearing in mind that with the longer beam arms, you want lower speeds, because obviously there's significantly higher forces on the unit. So while theoretically you could run a 5-meter arm at maximum speed, it's going to reduce the life of the system. So typically go with generally no more than the speeds that would be set by default, but you certainly could reduce. So if you had, for example, a 3-meter arm, you could close it slower or raise it slower if you wished. Next parameter is BU, which is our bus devices. This is by default set to no. I'm not going to touch on the bus devices again beyond the scope of this presentation, but suffice it to say that the control board can work with any of the FAAC bus to easy devices. So that's PE beams, keypads, etc. The next parameter, which is a very important one during your installation, is the Deadman motor operation mode, which is the M1 parameter. When you select this, you'll see a double dash on the screen. If you press the plus button, you'll see OP on the screen, and we expect the beam to open. Or if we press minus, we'll see CL on the screen, and while we're pressing that button, we expect the barrier to close. This is ensuring that our barrier rotation is correct for the site, given the fact that we could have either a right-hand or a left-hand barrier. So in half your cases, it's going to be correct, in half it's going to be incorrect. What happens if it's incorrect? Okay, so in other words, we've pressed the plus button and the barrier lowers rather than raising, or we've pressed the minus and the barrier raises rather than lowering. We then have to swap our two motor wires around. So we go to J23, which is where our motor is connected, and we swap the two motor wires around, which then corrects the error in the motor direction. And that then ensures that the barrier is raising. The controller knows the barrier is raising when it's expected to raise, and vice versa. So it is important to utilize this Deadman operation to get your motor direction correct before we move to the next step, which is the actual limit setup. And this is where the control board, together with the encoder and the end stops, sets up the travel on the barrier. So TL is going to be used to acquire the limit switch position. We've now confirmed that our boom gate is running in the correct direction using the Deadman setting. And we now perform a setup by going to the TL parameter showing dash dash. We keep the plus and the minus buttons pressed together for around 3 seconds, when we'll see 51 start to flash on the screen. We'll then release the buttons, and so we'll see the beam begins to close, and it stops when it reaches the end stop in the lowered position. At that point, 52 will flash on the display. The beam will remain in that position for a couple of seconds. The display will change to 53, and the beam will begin to open, and it will stop when it reaches that fully open stop, at which point the setup is complete, and we would expect to see 01 showing on the display on the status of the automation. At that point, we can leave programming mode by getting to the ST option, select yes, and press the F button to confirm. That's when we should see the 01 showing the barriers in the open position. At any given point under normal operation, the status display shows the status of the boom gate. So if the barrier is closed, it'll be 00. If the barrier is opening, it'll be 05, etc. 04 will show that the barrier is open, waiting in the pause, waiting to close. So that the default purpose of those 2 digits at any given time, if you're not programming the unit, is to show us what the status of the automation is. So that was the basic programming and covers pretty much all the basic settings that you would need on a site. There are, however, some advanced settings which can be taken care of in the advanced programming, which we'll go through now. So to access the advanced programming, very similar to basic programming, except that not only now do we press and hold the F key, but while we're holding it, we press the plus as well until the first advanced function appears. And then from there on, the program is exactly the same. So to enter advanced programming, note you press and hold the F button, and while you're holding that F button, you press the plus. That takes us into advanced programming, and we'll see the very first parameter. We then obviously release the F button, the F and the plus button, and we proceed through programming, modifying using the plus and the minus as before, pressing F to confirm the value, and all the way through to ST as we saw before. So the very first time we enter advanced programming, press and hold the F button, press the plus, and you will see the parameter PF, which is for pre-flashing, release F and plus, and you'll see the default for pre-flashing is no. This is the pre-flashing of the warning lamp if it's fitted. If you do want that warning lamp to flash, you can select OC, which will pre-flash that warning lamp for 3 seconds before each movement. But by default, there is no pre-flashing of the warning lamp, and there's no pre-flashing delay before each movement. The next parameters you'll come across are FO and FC, which are the opening and closing forces on the boom. As you can see, the default is 50 on both of these, which means maximum power for raising, maximum power for lowering. There may be certain cases on certain sites where you want to reduce the closing or the opening force, and that can be done at this point. But you need to just ensure that if you do reduce that, closing or opening force, there is enough force set to ensure that barrier will move the beam through every possible adverse condition. In other words, when the wind blows, etc. So if you do reduce it, you want to just do some tests to make sure you have got enough push force. The next parameter, the SP parameter, reconfigures the stop input. We did mention earlier that that stop input can be changed to an input for a closing photo beam. The default is 00, so it's defined as a stop input, but it can be changed to 02, which will then modify that input and make it work as an input for a closing beam. So in other words, if the beam is broken, the barrier will stop and reverse. And if the barrier is in the raised position, breaking that beam or opening that input will prevent the barrier from lowering. Next parameter is the operating time. This is one that you're probably never going to use, but this basically just configures how long the motor will run for if it doesn't reach an end stop for some reason. Something fails. How long will the motor run for before reaching an end stop? The only thing to note if you do change this value is to ensure that the time you set is longer than the time the barrier needs to open or close completely. So the default of 5 minutes here is going to be far more than adequate. If you wish, you can reduce that to 10 seconds or so, but generally no one's going to play with that value. Next parameter is the output 1 configuration, O1. By default is set to 00, which means that output is always active. So these are the 4 open collector outputs that we looked at earlier, and they can be used to indicate a number of conditions. As you can see from the list below, you could use it as 03, which is a courtesy light. You could, for example, set it to 07, in which case it will only be active when the barrier is moving. 06 will only be active when the barrier is closed. So you can use these outputs to perhaps signal to a building automation system or a traffic light system under various conditions on the actual boom gate. And output 1 can also, in the next parameter, be set to either be normally open or normally closed. So to either be normally active or normally deactivated, depending which way around you want it to work. Note that outputs 2, 3, and 4 are configured in exactly the same way. So they're just simply duplicates. So you can have 4 distinct outputs, each indicating a different state. Perhaps 1 active when the barrier is open, 1 active when the barrier is closed, 1 active while the barrier is moving, etc. They're all configurable in exactly the same way. So I'm not going to duplicate that in any particular slide. The one specific case is if you do set output 1 to be a courtesy light, there is another parameter, the next parameter, TO, and that defines the timing of that courtesy light output between 1 and 59 minutes, the default being 2 minutes. So if you were using output 1 as a courtesy light, it would be active for 2 minutes every time the barrier is operated, unless you make a change to the TO output 1 timing parameter. The next parameter, BF, relates to battery operation. As we have mentioned, there is an option to have a battery backup on this unit. So the default for battery operation is 01, which means that when the power fails, the boom gate continues to function until that battery is completely dead. You can configure the battery operation 02, which means that when the power fails, the barrier will open as soon as the mains power is interrupted and obviously remain open, or 03, which will close the barrier when the mains power is interrupted. So you just need to look at whatever the specific site requirements are and set the battery operation accordingly. There is a setting for the OS, which is for the integrated flashing light. Now, these are the optional red and green lights that fit in the cover of the barrier. It's an optional accessory that can be used as a form of traffic light. By default, 01 is the setting, which means that the lights are steady green when the barrier is raised fully up and waiting to close, and then it'll be red and flashing during movement and steady red when the barrier is closed. So largely like a traffic light with a bit of a warning while the barrier is moving. If you wish to just simply have that as a flashing red light during movement only, you can change the OS setting to 02. Remember, this is an accessory. It's not standard with the barrier. It needs to be ordered as a spare part and then fitted to the cover and plugged appropriately into the control board. Similarly, we have a beam light. So this is a rope light, a string of red LEDs that are fitted on the top of the beam underneath the red translucent cover. And by default, these lights will operate, they'll basically be on when the barrier is closed. So it's very visible to show that there is a barrier in the way. When the barrier is fully open, those lights will turn off, and during movement, they will flash. You can also select 02, which means that the lights will basically be flashing at all times except when the barrier is fully open. These beam rope lights are effectively also available as a spare part and can be fitted if required. The next and the final options in the advanced program are options that are very, very seldom used, but they relate to what we call the maintenance request and cycle counter. And so if the default is no, which means that there is no maintenance request set. If you do wish to set a maintenance request, you can set this to yes or active. And what that means is you will preload a number of cycles, after which the control board will indicate through the warning LED that there is service required on the boom gate. So if you do set this to a Y, a yes, the next two parameters, which are the small n, small c, and the small n, big C, you would configure how many thousands and hundreds of thousands of operations you want the barrier to reach before signaling to the end user through the warning light, through the flashing of the warning light, that a service is required. So you might say, well, every 50,000 cycles, I need to come and service this unit. So you will put 50 into the thousands, you'll leave 100,000 as 0. And after 50,000 cycles have completed, a warning light will start to flash, which indicates to the user that he needs to call you in for a service to his bin gate. If you don't set up the maintenance request, then the cycle counters will just indicate how many thousands or hundreds of thousands of cycles the barrier has done. So it's quite a useful indication, at the very least, just to see how many cycles this bin gate is doing on the site between visits. The next thing we will look at is the OmniDeck radio receiver. So the control board will take, it has a socket for the XF433 OmniDeck receiver, which will plug in, paying attention obviously to the insertion direction. It can only go in one way. It is an OmniDeck radio receiver, which means it will work with either the RC or the SLH long-range remotes, will work with both of them at the same time. So you can store both types of remotes on the control board at the same time. So having inserted the receiver, if we want to learn a new transmitter, if we want to learn to the opening function, we will just simply press and hold the plus button on the control board for 5 seconds until the radio 1 LED begins to flash. Or if we want to learn the transmitter to the closing function, we'll press and hold the minus button for 5 seconds until the radio 2 LED begins to flash. And then within 20 seconds, we'll press the desired button if it's a RC remote control, or we'll place the transmitter into teaching mode if it's a SLH or a long-range remote control, and then press the desired button. I'm not going to go into the ins and outs of remote controls. That's covered in a separate training session. But as you can see, it's just simply a case of putting the control board into learning for either opening or closing, and then learning the appropriate remote control within the 20 seconds. After the 20 seconds, the controller leaves learning mode, and the remote controls will then activate the bin gate as required. The last thing with remote controls, if you wish to delete all the remote controls on site, you simply press and hold down the minus button until you see the 2 LEDs, DL4 and 5, which are radio 1 and radio 2. You'll see they eventually come on solid. You release the minus button, the 2 LEDs will turn off, and all the remote controls will have been deleted. That's a very brief summary of the remote controls in the unit. The emergency battery, that drops into the base as shown by the red arrow. So you position the battery in the base and then simply plug the lead into connector J8 on the control board. That's the 4-way connector. And then all that remains is just to ensure that you've set the desired battery operation using the BF function or the BF parameter in the programming that we touched on earlier. And then your unit is ready to go. If you don't set that battery function operation, as said, the default is 0, 1, which means the barrier will continue to run in the event of power failure until the battery is completely dead. I'm going to touch briefly on synchronized barriers, which is the master-slave configuration we spoke about earlier. So for synchronized barriers, it is not 4 as in, but 2 barriers that are synchronized. So it's possible to connect 2 counterposed B614 barriers with synchronized movement. So what we need to do when programming is we define one of the barriers as the master and the other as the slave. We interconnect the 2 barriers with a polarized bus-to-easy connection. So the bus-to-easy connectors on the 1 barrier on the master get wired to the slave with note taken of the polarization. Generally, bus-to-easy connections are not polarized, but for synchronized interconnection, they must be polarized. So basically 1 to 1, 2 to 2. Once you've done that, you then program each of the barriers on the basis of the length and configuration of their own beam. So you could have, for example, a 5-meter barrier and a 3-meter barrier, for example, to close off an 8-meter driveway, or a 4 and a 4. But you need to specify on each of the controllers the default value or the configuration value for its appropriate length and configuration. And then effectively any control devices and loops that are connected to the system must be connected only to the master barrier. So, and in addition, the functioning logic is only programmed on the master controller. So if you have a look at the table on the right-hand side of the screen right now, obviously both units, master and slave, have a power supply. They've got a motor, an encoder, they've got head lighting, beam lighting. Those are all independent per barrier. Control devices are only to the master unit. Loops are only to the master unit. And then both outputs and flashing lights are then specific to each particular unit. And once you've got this all wired up and hooked up and set up, everything is done via the master controller gets operated, and the slave barrier will follow the master barrier with raising and with lowering. So quite handy when you've exceeded the 5-meter limitation of the B614, you need a larger driveway, you can always put in 2 counterposed barriers, in synchronization. Just remember, you do need power on both sides, and you obviously need at the very minimum the 2 cables to interconnect the bus connections between the 2 units for that synchronization. Right, looking at some of the accessories that are available for the B614, we have an adjustable foot that fits on the end of the beam, generally for the longer beams, just to provide a little bit of extra stability when the beam is lowered. There's an adjustable fork, which does a similar job, but obviously needs to be mounted in the driveway. A hedge kit, this can be mounted on the bottom of the beam, and the intention there is to prevent pedestrians from typically ducking underneath the beam and make it more difficult, and therefore make them more likely to not be involved in the area where the barrier is running for safety reasons. There is a beam lighting kit that's allowing you to connect your lights to the control board. These are the LED rope lights that run along the length of the beam itself. That is only red LED, or LEDs are only one color, the red LEDs, to just create more visibility to that beam in adverse light conditions and at night. And then the headlight set. The headlight set is the lights we spoke about that fit in the cover of the unit, and those provide you with red and green traffic light-like indications on the actual head of the unit. And then very lastly, we have the option of a joint kit. Not as exciting as it sounds, but that's just an articulation kit that allows you to split the beam into 2 pieces where you've got limited headroom. So all those accessories are available with the B614. Just again, bearing in mind, if any of the parts that are fitted relate to the beam itself, they need to be catered for when you're selecting your spring for that particular beam in your spring selection tables. So that brings us to the end of the presentation. We have now time for some questions and answers. So what I'm going to do is I'm going to select all of you and unmute you so I can hear everybody now. So if there are any questions from anybody who's in attendance, please feel free to fire them at me now. Any questions, guys?
Any questions? So the master slave control that's been included is just used via the bus connection to synchronize not the outputs themselves. No.
So Paul, if that's you, I'm struggling to hear you a little. I heard you asking about master slave control. Could you maybe just speak a little bit closer to your mic?
Oh, sorry, Ross, didn't realise we're all wearing face masks as well.
That'll explain it. Yep, sorry, do you want to just ask your question again there, Paul?
Go on, bro.
So to master slave synchronization, is that just using the bus to easy connection of the outputs?
Yes, that's correct. So similarly to the B680 barrier, that also supports the same configuration. You need to just literally wire those 2 wires. So obviously each barrier has its own power supply, but the interconnection is simply the 2 wires. It's bus to bus, but you need to obey the polarization. So in other words, terminal 1 on the one goes to terminal 1 on the other, and 2 to 2 on the other. Once you've done that, the 2 will communicate. You'll set the one up as a master, you'll set the other up as a slave. All your controls is done on the master boom gate, and the slave will just simply follow the movement of the master.
All right, maybe. Only other question I've got is during the installation instructions that you went through, you referred to the end stops as end stops, but then halfway through switched to limit switches. Are they actual limit switches or end stops?
No, they're actually not. So in the documentation, for some odd reason, they do refer to them as limit switches. They're not limit switches at all. They are actually physical mechanical end stops. They have little integrated springs to sort of soften them a little, and they are adjustable through a small range. So in essence, the position control on the boom gate is done via an internal encoder, obviously using the end stops as references. So while the manual does talk about limit switches, no, they're not actually limit switches per se.
Yeah, no worries.
No, that was, yeah, great. I think that's it, guys.
Welcome to hospital.
Okay, yeah. We did install one of these, Roz. I think it was it like 5 metre?
5 metre. No.
Yeah, it was a 5 metre. Now, at the time, it was the first one we installed, and we didn't put a leg or anything on it, and it did start to sag. It has started to sag. So what's your recommendation on what size or above should have some support? Because it doesn't really say in the manual.
Yeah, correct. It doesn't specify, but I would probably say sort of anything from 4 meters upwards, you probably want to have a little bit of support. You know, besides the internal mechanism, the arm itself obviously has some flex in it, and so they do tend to bend down a little. So I would say probably from, you know, maybe four and a half upwards. Probably either put on the foot or better still the hedge, not the hedge, the catch post.
Yeah. We're going to put a leg on it and just change the spring if we need to. So that's fine. Yeah.
Yeah, correct. And yeah, so anything that you do add, just go back to the balancing tables, and where required, you might have to add that second spring depending on the length.
Yeah, that's great. Anything else, Simon? No. Cool. Well, that was really good. Thank you, Ross. That was we've had 5 of us in here listening to that, so very worthwhile. Thank you very much.
No, you're welcome. Thanks, guys, for attending.
Cool. Thanks, Ross. Catch you next time.
No worries. Anyone have any further questions?
No, we're all good.
Okay, great, guys. Thanks very much for joining us. The session has been recorded and will be available via our YouTube channel. You will be notified if you ever want to go back and brush up on anything. And of course, at any point, the manual itself is quite comprehensive, but we're obviously always at your disposal with any technical questions you might have. Just ring us up and we can help you from there. So thanks very much for your time, guys. Thanks for joining us.
Cool. Thanks, Ross. Cheers, mate.
Thanks, and bye-bye.